There we go. Cool. Okay. Hi, everyone. Welcome to Arduino Beginners Arduino Circuit Workshop. I'm Ravni Panu. I'm project manager for SWE. And
I'm Brian Rogers. I'm one of the free mentors for IEEE.
Okay, cool. But yeah, today, the materials that you are needing is none, which is really exciting. Yay. But we would like for everyone to have a Tinkercad account. I hope, does everyone have a Tinkercad account, or should we take a moment to make one?
If not, you can always follow along on my screen. So don't worry, if you don't want to make one, it's totally fine.
That's also very fun. Okay. Okay, and now there we go. Cool. Here's all our platforms, Discords, IEEE, SWE Discord, also the websites that we're using. Instagram and YouTube. So this YouTube link is where this is recording for the Zoom meeting will be. So if you end up missing parts of it or anything else, you can always come back. Okay, steps to take beforehand. Brian, could you share the Google Doc in the chat?
Oh, sure. Yep.
Yeah, so basically what we're going to be doing is we're going to be playing around with circuits on Tinkercad. So you don't really have to have it. If you physically have the circuits, that's awesome. But if you don't, you can do it on Tinkercad, and there will be a Google Doc that you can also look at, which will be the coding for this. So the main focus here is more circuits, but there's a little bit coding involved too. Okay, awesome. Okay, the first module, I think this is Brian's realm.
Okay. Hello, everyone. So for this part, it's going to be on the testing of the Arduino. So basically, you guys are probably wondering, what's an Arduino? It's basically a microcontroller. And you're probably like, what in the world's a microcontroller? Well, what you guys need to know, basically for an Arduino, is we have inputs and outputs. That's the major part. So we often refer to this as I/O for inputs and outputs. And what we're going to be doing here today is, you'll see in our little Arduino here, is we're going to have an LED here. And also we're going to have a resistor right here. And we're going to hook that up to create the most simple circuit you'll see in electrical engineering, basically. And what else needs to happen is we need a source of power, because in order to make an LED light up, there has to be some source giving power to that LED. And then we also have to connect it to ground, because that power has to finally reach an endpoint. So what you're going to be walking through, just in a simple little diagram here, is it's going to be a voltage source, which is going to be around 5 volts. And that's going to provide the power to the circuit. And we're going to have our LED. So I'm just going to make a little shape here, sort of like a bulb here. You can also, if you want, because an LED is a diode, which you might have heard of, might have not. It's a light emitting diode. That's what it stands for. So it gives off light here. And we're going to have a resistor. The part the resistor plays in the circuit is that it controls the current flow, because that LED has a certain rating and we don't want to exceed it. So we don't want the LED to get too much power, because it might go above the rating, or if it gets too low, it won't light up. So we just want to make sure the LED stays within a good range. So for this one, we use a 220 ohm resistor. And then we finally are going to have it connected to ground here. So at the other terminal, it's going to be connected to ground. So then that's where the source will run to. So it completes the circuit. We have the beginning and we come back to the endpoint. And so that's what we're doing, the main basis for number 1. And so what you're going to need for this through Tinkercad is the Arduino Uno. And this would be if you actually had the module to transfer the code over. However, you won't need this on Tinkercad. And then you'll need an LED, which you can see right here. And you'll need a 220 ohm resistor right here. And so I'm going to walk you through how to set it up in Tinkercad and how to do the coding. So Rovnet, are you good
Stop
with
sharing? Yep.
stop sharing, and then I'll start sharing. So okay, so let me close this. Go into okay, so I logged into Tinkercad, and what you guys are going to do for your first time is you're gonna what I like to do is I search up here and I put in Arduino simulator Tinkercad. And when I type that into Google Chrome, basically in the search bar, what someone has done before is they've created already the simulation for the Arduino. So we're just going to manipulate it for our purposes. And so I'm going to click on this first one here. And when I click on the first one, I hit copy and tinker. And when I hit copy and tinker, you can see what's going to happen is it's basically going to create a copy of their circuit, and we're going to modify it for what we want in our circuit. So I'm going to split the screen to show what we want versus what they have. So here will be on the right what we're going to be building, and then let me get up the circuit on the left of what we want. So right now we're going to be dealing with module 1, which is the test Arduino. So it's going to look something like this with our LED and resistor. So when we copied it over, it looks something like this. So we're going to have to modify this for our board. So I'm going to delete what they had originally there. So I'm just going to delete everything except the Arduino. So let me delete all the other parts they had in there. Delete. Okay, so now we're just given our basic Arduino right here. And what we need to do is we need to hook up our LED. And so I'm going to throw my LED there, and I need to have a resistor hooked to one side of the LED. And for a resistance value, it's going to be 220 ohms. And so here I typed in 220 when I clicked on the resistor, 220, and then it's in ohms. I changed it from kilo to just regular ohms because kilo is 10 to the 3. And so we wanted it just in basic 10 to the 0. And now what you're going to have to do is, in order to complete the circuit here on the right, you're going to have to connect it to a power source and also a ground. So for a power source here, we're going to connect it to pin 13. And so I'm going to drop it in pin 13 because that's an input or output pin of the Arduino. So it's going to output of voltage, and here at the resistor, we're going to connect that to ground. So what I showed you in that simple diagram of the voltage source that's coming from here, pin 13, it's running through the LED, then through the resistor and back to ground. Okay, now that I showed you how to do that, we're going to have to code it. And I'm going to walk you through each step of the code. So that document I gave you guys in the chat, you can click on the link, and what that link does is it's going to open up the collaboration code here. And for module 1, I'm going to copy over all this code here. So I'm going to also paste that in the chat box in case oops, sorry, any of you guys need it and just want quick access to it. Oh, looks like it's too much text. So if you could just open it, that would be good. And so you'll just copy the code over from the shared Google document. And then in the Arduino simulator, you're going to hit this code editor here. And what I want to do is we want to delete all this code here. So we're going to hit, on mine, it's Command A, delete all of it, and then Command V for a Mac, and paste it in. And so let me walk you through how this code works. It basically just gives instructions to the Arduino on how to operate. So we start here. You can see we have a comment here because the comment is surrounded by slashes and star, and then it ends with a star and slash. And so within here, this is all just a comment of the sketch where we got it from. Okay, now getting to the actual coding part here. Within this body, that's your most important program for the entire module. And so the setup code's gonna run once and the loop code is gonna run over and over again. So whatever occurs in the setup will run one time. Whatever occurs in the loop is gonna run over and over and over. So it's gonna keep looping. So at first, we're going to declare a pin mode for 13. So pin 13 here is going to be an output pin. So it's only going to send an output. We're not going to take any input in from that pin. And then within our loop code that runs over and over again, pin 13 is going to be set to high. And so that means it's going to, if you think of it, 0 is for off and 1 is for high. It's going to be set for 1, so high, and that's going to mean the LED turns on. It's going to send out voltage, where then after we're going to wait 1 second. And you're like, oh, but it says delay 1,000. Well, that's in milliseconds. In 1,000 milliseconds is in 1 second. So we're going to wait 1 second, and then pin 13 is going to go low. And so that means the LED is going to go off at this 0 stage. And then we're going to wait 1 more second, and then we're going to repeat it. So the LED is going to go high, so turn on, and then low, turn off. So it's going to do that over and over again. And we're going to see this when we run the code. So going down, scrolling down, the rest is just comments here. So this is the main embodiment. So I'm going to make this full screen now. And when I hit start simulation, what you're going to see right now is pin 13. We have a pulse coming through where the LED is going on and then off and then on, then off, then on and off. And that's what's happening. Like in our code, it's going on and off this LED here. So that's the first module. What we wanted you guys to see is the basic workings of how to make an LED go on and off. Hopefully that made sense for everyone. And if you guys want, I can continue. If anyone wants to wait and assemble it, we can wait as well. If no one responds, then I'll move on to the second module. Okay, it sounds like everyone's good. So let me explain what our second module is going to do. So let me pull it up just so you guys can see an image of it beforehand, and then I'll tell you exactly how it works. So right here, for a second module, we're gonna have a breadboard, and we're just gonna connect the wires to a breadboard. And just a little quick intro so you know how a breadboard works is all the pins are connected along the rows here. And then all these pins here are connected along the bus. You call these 2 buses where the positive and negative leads are. And then all these in the rows of the breadboard are connected. So what we have here is we have our ground and we have our voltage supply. And so for ground, you can see we hook it up from the ground pin of the Arduino, and it goes here into the ground. Oops, right here from the ground. And then for pin 13, we have it still connected to the LED here. And then the resistor here that's connected to the other side of the LED is connected to that ground. So it looks like this, all the connections here. And so it's the exact same thing as the other one, it's that we include a breadboard this time. And so what we are going to do is I'll show you how to assemble it. So basically what I'm going to do is I'm going to go back to that Arduino simulator through the Tinkercad, just like the first time. And I'm going to hit copy and tinker. So we'll just get a sample of it and we're going to modify it to what we want over here on our left-hand side. And so for this, we notice that we're going to have our basic breadboard, our Arduino Uno, and we're going to attach all the wires here. And so we'll build this together and then I'll explain how the code works after. So just you have to go through and delete all the components that you're not going to use in the module. Okay, so now we're ready to hook up the ground to the ground bus terminal here, the negative one. And then we're going to put in the resistor. It's going to be the same resistance, which is 220 ohms. And then we're going to put in an LED. And we're going to hook the other side of the LED to pin 13. And then we're going to put in the code here. And for the code, you can see right down here, we're going to copy it over again. And what you're going to notice is this code looks exactly the same as the last code, because all we did is we just had a breadboard here to show how it worked. So we're going to declare pin 13 as an output pin. So on our module, pin 13 over here is an output. And then the code that's going to run over and over again is basically turning on and off the LED. It's going to be on for 1 second and off for another second. So when we start the simulation, you can see right here, LED is going to go on and off, on and off. And so that's just like the first module, just like I repeated before, it's just adding a breadboard. So you can see how a breadboard works. The main takeaways are breadboards have their rows all interconnected and the bus terminals are all interconnected. And now I'm going to go into the next module. So this one will actually have something a little different, spice it up. This one, we're going to be working with a push button. So push button is like a button you press and it gives a specific output. And for this one, what we're going to do is I'm going to modify the one I'm working on right now because we can see it has the same setup. We just have a few more components we have to add in wires. And so right now, I can notice they connected the 5-volt pin down here, which is the pin right here. They connected it to the bus terminal. And along this positive bus terminal, there's going to be 5 volts distributed along it. And then they had another wire going to the other side of the breadboard here. And they had a resistor. And so I'm going to put a resistor in on this side. And I'm going to want to flip it to the right. So I'm going to click it here. Oops. And for this resistor value for module 3, we're going to have to modify it. And I'm going to check that value real quick to make sure I give you the correct one, because you have to do calculations based off the what it is. And so for this one, we had up here, the resistor value was set at 10 kilo ohms. So here I'm going to click on it. Okay, this one's not wanting to work and change. So here, let me just delete it real quick and I'll put in a new one. And let me set this one to 10 kilo ohms. And let me rotate it to the right real quick for you guys. And now I'm going to hook up the push button. So push button, you guys need to get a little familiar with, so I'm going to draw it out here. What a push button does is it has 2 terminals here, and it has another 2 terminals on this side. So it has terminals on both sides. And what's the interesting part is that 2 of them are interconnected to the button. So it depends on how it's laid out. So what you guys need to know for this one is that these 2 are connected on this side here. So I'm going to do different color. And these 2 are connected as well. And so that's an important takeaway, is that a push button has connections across, and you need to know that this pin here will be connected to this one here. And so when you push the button, it's connected. It's going to connect those two. And it's also going to connect the two on the other side. And so what we're going to do is we're going to add in a wire to connect it to the other end of the resistor here. So I'm going to move it to the resistor. And I'm going to hook this up to pin 2. And then you're probably wondering, why do I need to hook this one up to the voltage? Basically, I need to hook this one up because we have to make sure when you push the button, it can toggle between 0 and 1. And that might cause an error when read, because like when you push it, like it's going between 0 and 1. It's not like staying at a consistent value. So when we hook it up to the voltage source, it's going to keep it at the high value for what we want. So it doesn't switch in between and make all this weird output. So what we're going to do now is we hook this together. And so when we push the button, it should turn on the LED. So let me give you a little recap on what's happening. Pin 2, oh, let me change the color. Pin 2 here is connected to one side, the push button. And that side, the push button, when we push the button, it creates a connection across here that's connected to the side of the resistor. And what's going to happen then is that push button will go back here to ground, so it completes the circuit. And then when the push button is pressed, it's going to send a signal back to the Arduino. Since we have an input pin here, we have 2 as an input, and it's going to trigger our LED to turn on. And then when it's not pushed, it will make the LED, it will send a signal back to the pin and tell the Arduino microcontroller to not have the LED lit. So let me now show you guys the code and I'll explain how it works. So for the code, let me go over here. I'm going to copy it over from module 3. And I'm going to paste it in the code here. Okay. So what this is up here is this is just comments, so we're going to ignore it. Okay, what happens up here is they declare some variables. So they make pin 13, they declare that as the LED pin, and they declare pin 2 as the push button pin. And so we're going to start at 0 for a state. So that means the button's originally 0. We haven't pushed it yet. In our setup, we're going to declare the LED pin and also the button pin. So pins 0, 2, and 13. The LED pin will be an output because that's going to have to turn on the LED. And the input from the push button is going to come to pin 2. So that's why it's an input pin. In here for the loop, what's going to happen is we're going to read what that push button says and assign that to a variable called button state. So if the push button basically says high, so that means you push the button actually. So that's why it's at the high. It's at the waveform of 1. So let me show you guys what it looks like. When it's high here, that means that when we push down, it gave us the result of high. We triggered it. It will turn the LED on. However, if it's not high, that means we want the LED off. So when I start the simulation here, we're going to see that when I press the button here, I hold down my mouse, it turns LED on. When I let go, it turns LED off. When I press down, it turns LED on. And then when I let go, it turns the LED off. So that's how it works here for the push button. Okay, so now you guys learned how a push button works. It works sort of just like a switch for your LED. Now I'm going to get onto module number 4. And module 4 is going to incorporate the skills we learned up to now. And so for this one, what's going to happen is basically we have to Let me go back to my circuits.
May I ask a quick question?
Yeah, go for it.
Is it possible to code for an Arduino in a language other than this one? I don't, this is C++, is that right?
It's just C coding here. It's
Okay.
the basic.
Yeah, so
I haven't coded in any other language than C. That's why, and it looks like Kio's only done C as well. So that's what I would say. It's a pretty basic language. And so that's why it's used for the Arduino because of its simplicity. I haven't seen C++ on it used before, but you could double check me on that. But the majority of what people code in here is just C coding.
Yeah, for Arduino, it's mostly only compatible with C. I think you could try going with other languages, but really like the easiest one, the one that works best is C.
okay, thank you.
Okay, any other questions before I get on to the next module? Okay, sounds good. So I'm gonna get on to module number 4 here. And this is gonna deal with a potentiometer. So remember I told you guys, oh, this is a resistor and it slows down the current. Well, potentiometer, what you can do is you can adjust how much resistance you want to be given. So you can either give a smaller amount of resistance, as seen here, or a greater amount of resistance. So that's what happens here. Is this potentiometer, I'm going to draw out with the resistor. So your resistance inside looks something like this, and it's going to determine how much it wants to cut off here. And so that's how you determine how much resistance you want to provide to the circuit for the potentiometer. And so let me now show you guys how you want to set it up. So what we need to do here is I'm going to use the original, and I'm just going to take away my push button. And I'm going to introduce my potentiometer here. So the pin on the very left is the ground pin. So I'm going to connect that to ground. The middle pin here, that pin is going to be the input. So what you read from the potentiometer, what it's going to give out. So what value of resistance. And my pin here on the very right is going to be the voltage source pin. So I'm just going to connect it here to the 5 volt because these are all interconnected. And so I connected the pins correctly. So going again, on the very left, it's the ground pin. On the middle is the output, and on the right is the power supply pin. And now I'm going to show you with our code what it does, and then I'll explain it. And you'll sort of see how like the potentiometer works. And so I'm going to copy this over. And so what you're going to see here is I declared the potentiometer pin as A0 here. So it's an analog pin since it's continuously changing. So like a sine wave, it's continuous. It's not like a digital. So there's a difference between digital, looks something like this, and continuous, which it keeps moving. So this is known for like zeros and ones for digitals, where analog is just continuously going and going and going. And so that's what you're going to have here. And so we're going to hook it up, and our LED is going to be set to pin 13. And the sensor value, the default one we're going to have it at is 0. And so this is going to be the variable that will store the actual value coming from our sensor. And then we're going to have our setup code. So here's where we declared our pin. So we declared the pin output for the LED. And then the loop that's going to run over and over again is we're going to be reading the value from the potentiometer to know how much resistance. And we're also going to be sending out a signal to turn the LED on. And then we're going to delay it by the sensor value. And then we're going to turn the LED off, and we're going to delay that by the sensor value as well. So it's going to run this over and over. It's going to keep reading that value from the sensor. And what that potentiometer looks like is going to do in this circumstance is it's going to tell you how much delay there will be from that sensor value. So let me just show you how it works. And then I feel like that's a better way to explain it. So right now we have our LED, you can see right here. And when I switch it around, you can see when I turned it to the very right, it's causing there to be a greater delay. But when I have it on the very left, we can see that right now the delay, it's so quick almost, it's like flickering on and off, on and off, on and off, that we only really see it on. And so it's faster, there's less delay. So here the delay is a lot slower between the two states, where here the delay is very fast. So when we had a higher value of resistance, that caused basically, it told us, okay, when we have more resistance, it's going to send that out. So we have a larger number, and that's going to create a larger delay. When we had it on the very left, that was a smaller number. And so it's going to create a smaller delay. And if you think about it, your light bulb in your house, it works on AC power because the power lines give you AC current, and it's literally going back and forth. So it's flickering so much, but you just don't see it because the eye can't see that quickly. So it just looks like it's on when the light bulb's literally just flickering all the time. And so that's one cool thing you can think about, sort of what's happening right here. Okay. Now I'm going to move on to the next module, which is module 5, fading an LED. And so this one will be pretty cool to watch because you'll see how you can slowly cause the LED to decrease its brightness over time. And so what I'm going to do here is I'm going to set it up just like my module here on the left. So I'm going to delete all the extra stuff that I don't need. And we're going to hook this up to pin number 9. Okay, so what's going to happen here is you'll see we'll have pin 9 supplying the current to the LED, which will have the resistor on the other side, and that resistor is going to be hooked into ground here through the negative bus terminal. And now I'm going to pull out the code and show you how the code works to program this LED to fade in and fade out. So let me copy that over here, go to the code. And so for my LED, I declared it under pin 9, since in pin 9 in the Arduino, the brightness. So how bright the LED is, we're going to store that in another variable. We'll set it default at 0, and that's going to change over time. The fade amount is how many points to fade the LED by. We're going to fade it by 5. And so now we're going to have our setup code, which declares the pins. So right here, we're going to declare the LED as an output pin. And so then our loop code that's going to run over and over again, we're going to have it write the brightness. So it's going to send out a signal as an output to this LED of how bright it should be. And then the brightness will increase with the fade amount. So here, so if the brightness, it ever falls outside of this amount here. So what I'm going to do is I'm going to create a number line so you can sort of see it. So we're going to have our 0 in our 255. And if the brightness is less than or equal to 0, so that means on this side, or the brightness is greater than or equal to 255. So on this side here, it's going to make the fade amount inverse. So once we reach that max brightness of 255, then we're going to want to fade it back to 0, and then we're going to want to go back up, get bright again, then get dull again, then get bright again, then dull again. And so that's what's going to happen here is we're basically going to switch the fade amount. So instead of increasing it by positive, it's going to now increase it by negative. And then we're going to delay it for 30 more milliseconds before. So let me show you guys just how this operates. So let me run the code here. And what you're going to see is it start simulation. It's becoming brighter, and then it reached its max and it went lower. Then it reached its minimum and went higher. So it's just adjusting the brightness. So it goes high, then it goes low, then it goes high, then it goes low. And so that's what's happening here. And then that's how you make a fading LED. Now for our last module, we're going to do a scrolling LED. So you're probably wondering, what's a scrolling LED? Well, here on the left, it's going to basically go from the left LED to the right LED, then back from the right to the left. So it's going to go on, off, on, off, on, off, on, off to the right, and then do that again, back to the left. So let me show you real quick how to set that up here on the right. So we're going to have 6 LEDs. So let me just modify this one here. So I'm going to copy this over. So I'm going to make 6 of these here. And then after we've done that, we're going to have 6 resistors in here. So let me just see which value I use for that one in order to give you guys the appropriate result. And so it looks like when we created this module, our resistance value was 220 ohms. And so I'm going to have the resistor, and that resistor, so you guys know, is going to be hooked up to the negative terminal here. So that's why it's connected to ground in the negative side of the LED. And then I'm going to copy this resistor over because we need 6 copies of it for 6 LEDs, 1 for each. And then I'm going to hook the other side of the LED to a pin, which will deliver an output current to the LED to make it light up. So I'm going to have to specify my code which of those pins are connected to which ones. And so here, the first LED here is going to be connected to pin 2. The next LED is going to be connected to pin 3. This third one's pin 4. The fourth one is pin 5. This fifth one is pin 6. And the sixth one is pin 7. Okay, now that I've done that, I'm going to hook the negative bus terminal to the ground pin here. And I'm going to now show you guys the code. So how it works. So let me copy this over and paste it in here. Okay, so what happens right here for my timer, it's going to be 100. And what's going to happen in the setup code is we have a for loop here. So it's going to start at 2 as our initial value, and it's going to go up until it's less than 8. So while that is true, and then it's going to add 1 to it. So it's going to go 2, 3, 4, 5, 6, 7, and then it will stop. And so right here, you can see we use pins 2 through 7 here. And so that's why we go 2 to 7. And then we're going to declare those as output LED pins. And then the loop, what's going to happen is in this for loop, we're going to write each LED as high and then delay it by the timer. So it's going to delay these by specific amount. And then we're going to write out to make the LED low. And so this is going to go from the lowest pin to the highest. And then in our other loop, it's going to go from the highest pin to the lowest. So it's going to turn the LED on, and it's going to delay it for a certain amount of time and then make it low again. So what's going to happen here is the LED is going to go from the lowest pin to the highest, and then from the highest pin to the lowest. So it's going to go from left to right, and then here right to left. It's going to run this over and over again. And so you'll see when we actually run the simulation, it's going to go from left to right and right to left, just like this code wanted here, from left to right and right to left. And it will delay it all by 100 milliseconds. So 0.1 second is going from each one. And that will be the 6 modules and how they work for your LED on the Arduino. Does anyone have any questions on the Tinkercad modules?
So we have this pin plus plus. Does the plus plus just indicate that it's increasing?
Yeah, so it's going to
it...
add 1 to, let me just draw this out. I feel like it's confusing a little because we have LED 2, LED 3, 4, 5, 6, all the way up to 8. And so what that plus plus does is it goes from LED 2 to LED 3, and then LED 3 to LED 4, then 4 to 5. It just increments it by 1. And this minus minus is going to do the opposite, where it's going to go from 8 to 7, 7 to 6, 6 to 5, 5 to 4, and then 4 to 3, 3 to 2.
Okay, cool.
That's how it works.
I just wanted to make sure that was part of the language. It wasn't like an integer that you're making.
Any other questions you guys have?
I do have one question.
Mhm.
So this is kind of like a more, I think it was in the first few modules primarily, but I think it kind of applies to all of them. But when you're making like an initial connection from like a port on the Arduino
Yeah.
to the negative bus, can it be like anywhere leftward of, like, say you have like a connection from a port to, you know, the negative bus, and you have all your, like the rest of, basically anything else on the breadboard is on the right-hand side. Does it matter which negative bus port you put that initial connection into, or does it have to be right next to the, like your first resistor, for example?
Oh, okay. No, it doesn't matter. I can put it anywhere along this bus. I just can't connect it on this one because this one's not connected. You see how it makes the green here? See those green circles around each?
Yeah.
That's where it goes to, where it applies. So it applies to all the resistors here. However, if I put it down here, it wouldn't apply to any of the resistors up there. It's not in that bus. So it's just along that line. It applies to all of them. So you could place it at the very right or the very left. It's still going to apply.
Okay, I see. So the whole breadboard itself is just like, it has like two halves to it almost.
Yes. So basically what you just need to know is the buses are connected all along their certain lines. The rows are all connected. And then these rows are connected to themselves. And then this bus is connected here and this bus is connected here. So you can think of this as one half and this as another half.
Gotcha. That makes sense. Thank you.
Any other questions, you guys? Feel free. Like, if you don't know anything, totally fine.
Would you be able to go back over the button module again?
Okay, the button module. Let me pull that one
I'd
up.
appreciate it.
I'm going to share my
Yeah.
screen with the presentation.
Oh, yeah. Go for it, Robin. Let me stop mine and
Oh,
then.
yeah. The button module, it's there.
Okay, so how the push button works is basically it allows you to turn on and off an LED. So here for a push button, it's connected. These two terminals and these two terminals are connected. So when you push the button, it allows for there to be a connection between the two sides. And so what happens here is you need to turn on and off the LED we want in this specific one. And so if we want to turn the LED on and off, what's going to happen is we're going to have to make sure the push button signal is going to be sent back to the Arduino and it can read it. So right here, what we have is we have a voltage coming in to this side of the push button. And that's allowing, so when we push it here, we're going to see that when we push the button, it's going to read it back to the Arduino. And so that signal is going to be sent back to the Arduino. And the reason we had a power connected here was just so we had a source going to that push button so it could actually read the signal. So when we pressed it, there was some supply given. So it was given power so then it can send that signal back to the Arduino. And then that signal coming back from the Arduino is basically what's going to drive the LED here. And that's going to make the LED turn on. And then that LED is going to be connected back here to ground, and that's going to go back to the Arduino. So that input coming back through pin 2 from when you push the button is going to be sent out to this LED here to tell it to turn on. And when you're not pushing it, it's going to tell it to turn off.
I got you. That makes sense. So for the push button,
Yes.
so those faint green lines are like or is that the direction of which you need to connect each Does it matter where you connect the wires on the push button?
Okay, Robinette, can you stop sharing real quick? I'm gonna show a diagram of what one looks like online. to have a
Thanks.
better understanding.
Sorry, I'm just trying to, you know.
Yeah,
trying to
they're weird. Don't worry, when I connected it wrong when I first did it. So let me find, okay.
Don't worry, the entire purpose is to learn.
And so here we go. This is what a typical one looks like right here. And so you can sort of see these two are on the same side, so they're connected. And then the other two are on the other side, so they're connected. You'll look at the modules, so you'll know which ones are actually connected and which ones aren't. And then you'll have a better idea, understanding. So it depends on the module you're using. So a lot of the times, if you look up push button connections, and you can find usually something here where it will tell you which two are actually connected. So when you press it, it will cause these two to be internally connected. And when it's released, there won't be a signal going through. And so the push button, it just is represented based off when you actually push it. And then when you're not, it's an open circuit, but when it's pushed, it's a closed circuit.
Okay, cool. I appreciate it.
Any other questions, or do you guys feel good? We'll have a recording of this posted, so don't worry. And also, if this is your first time seeing it or breadboarding or anything, it will be confusing, but don't worry, you'll see there will be a lot of videos, and the hands-on experience really helps with this too.
I do have one other question.
Mm-hmm.
Do people ever like connect Arduinos to something other than a breadboard?
I connected mine to a fan. That was for my final project because I could do pulse width modulation on it. So it could send out a signal to the fan to go faster or slower, so it could determine the fan's speed. And so that's what I used it for one time. So you can connect it to other devices to power them.
I have also connected them to, like the LED string lights that you see on like TikTok or something. I have connected them to those and then connected to a Google Home. So really, Arduino is just like a bridge for everything.
Mm-hmm. It's like a small computer, so you can give it a lot of inputs and outputs.
Yeah, that's pretty cool. So it's like a way to translate your code into like whatever you want to apply it to.
Yeah, it's like a drive, sort of. You can drive other devices off the Arduino.
That's awesome. I didn't know that.
Any other questions or concerns?
Can you share that ICEE PowerPoint?
Oh yeah, let me stop sharing.
I don't know if you guys mentioned that in the beginning or not.
Oh, wait, do you want the link or?
If you could send the link, that'd be awesome.
Yeah, for sure. Here it is. Brian, do you have the link to IEEE's YouTube page? So they can also have that. So if you guys ever want to go back and like go over the basics again, because it goes by pretty fast, you can always check the recording for this again.
Ooh, another question. Will there be like a sequel to this presentation? Or is that undetermined?
That is up in the air.
I have an Arduino workshop, actually one already posted there. So if you do want to see a sequel, that one's actually hands-on with it. It's in that channel, so the YouTube channel. I created that in the beginning of the year for the 10-week workshop, but I will be having to stop soon with finals because I did 10 weeks. So this is my last week presenting for the mentor team, but they're all posted there, like all 10 weeks. So you can see like all the beginning classes of electrical engineering. If you want like any information, it is posted there.
And SWE will also probably be working on more workshops, probably not for this semester, but most likely for sure next semester. So if it's wanted by our members, we will gladly do an Arduino part 2.
Awesome. Thank you. I will definitely check out that YouTube channel.
Okay, does anyone else have any other questions?
Okay, thank you everyone for attending.
Thank you
Thank
so
you for your
much. We
time.
really appreciate it. Okay,
No,
I'm
thank
gonna
you.
stop the recording.
Thanks.